Hi Matchcan. I'm recording this video just to satisfy you because you've asked a question um, yesterday and I didn't find time to respond to your email straight away, but I'm doing it now. So your question was, I'll show you what task your question relates to. So you've asked me a question from this worksheet called Bohr Model Worksheet, which is task number 3 for this week. Your questions were, what do the elements in each group have in common and what do the elements in each period or row have in common? Before I answer this question, I need to stress on one thing. We'll be doing periodic table in much detail next week. So if in case you still cannot, after I finish, if in case you still can't do this question this week, leave it for next week, okay? But let's start looking into what they're asking us. First of all, before you respond to this question, you need to have a clear understanding of the periodic table. So either you can access the periodic table sitting in this PowerPoint, or you can access the periodic table from today's class discussion, because you were not in the class, so I couldn't respond to your question straight away. When I was discussing groups and periods, I had referred to the periodic table shown here. And I had stressed on the fact that two things that you need to know about when you start thinking about a periodic table, the periodic table actually, there are 18 groups and 7 periods in the periodic table. So what information can you get from the periodic table? First of all, why do you need to know about this? Because when the scientists were trying to arrange the elements as they were discovering these with time, they felt the need of putting the elements in a meaningful way so that a few things could be explained. Like there were so many experiments being conducted, there were so many questions being raised in the scientific world about atoms, about chemical reactions, about the structure of the atom, what was inside it, where is everything sitting in an atom. So when the scientists discovered the elements, they started thinking about how can they put together all of these elements as they are being discovered. So many efforts were made, and one of the scientists called Mendeleev, his model of the periodic table, or his way of sorting the elements in a particular way, was accepted. This table, which you can see, is also called Mendeleev table of elements, okay? Because that's just his work. We'll talk more about it next week, but this is just giving you the starting point. Why do you need to learn this periodic table? Apart from that, when you look at this table there, it has been arranged, all the elements, they have been arranged in 7 rows and 18 groups. Now, what do you mean by groups and what do you mean by rows? Let me tell you now. When I was trying to copy this, I couldn't copy the maximize. I'm trying to maximize the screen. Can't. When I was trying to copy this periodic table, I couldn't copy the 7th row there. This is missing. Alright? But there are 7 periods or 7 rows in the periodic table. First, second, third, fourth, fifth, sixth, and 7th, which is missing. 7 rows are called 7 periods. Alright? Each period has got special properties. Each period has got some special kind of elements. There's a reason why these elements are in the first period, or in the second, or in the 7th period. In the same way, in the periodic table, there are 18 groups. And there is a good reason why Mendeleev had put together in columns all of these elements. I'll count with you 18 groups now. 1, 2, 3, 4, 5, and so on. You'll reach the 18th column there. Oops. There is something wrong with the way I'm accessing OneNote. Now I'm able to. This is the 18th group or 18th column in this table. So, for your information, there are 18 columns in this table. The columns are called groups. There are 7 rows in this periodic table, and the rows are called periods. And they are fixed. Okay. This periodic table, which I have shown you here, has got 2 colors, green and blue. But the periodic table, which I'm going to be using next week, will be bearing different colors. Just because I will be stressing on the properties of different elements using different colors. And that will be even more helpful. So, going back to your question, now you know there are 7 rows or 7 periods, and there are 18 columns or 18 groups. Your question I can access from this week's timeline. What do the elements in each group have in common? Now I need to go back to the periodic table again. If you pick up any one group, let me pick up the 18th group. Bear in mind, if you just focus on any of the groups, bear in mind, whatever elements are included for that particular group, all of these elements have the same properties, physical and chemical properties. For example, in 18th group, I have got these elements, okay? Helium, neon, argon, krypton, xenon, and radon. All of these 6 elements have got the same properties. They are all noble gases. They are unreactive gases because of some reason. We'll look into that reason later. But I'm trying to tell you, for each of these groups here, whatever elements are sitting in any of the groups, they are sharing the similar properties. They are just the same people, okay? Now, your question was, what information or what do the elements in each group have in common? Now, if you have a look at the 18th group here on this worksheet, you will come to know these have got the same number of electrons in the outermost shell. Quite a difficult thing maybe, I'm telling you, but that's what's actually true. How can you answer this question by yourself? You need to do style lessons first, and then this model, and then this task worksheet. Otherwise, you can't understand what I'm saying. All right. I'm trying to tell you is the elements in each group, they have same number of valence electrons. What are valence electrons? The electrons in the outermost shell. I'm sorry. Eraser. My spelling mistakes there. Oops. My eraser doesn't seem to work. In the outermost shell. Let me read the sentence myself first. I have written for you, the elements in each group have same number of valence electrons for any group. For example, if you take into consideration group number 2nd, you will see they have just the same number of electrons in the outermost shell. I'll show you when you finish this worksheet, then you will see that. But let me show you my answer to this task, or let me show you quickly this thing. So this is the answer to that task, okay? As you can see, for 2nd group, this one, I can't write on that, I'm sorry. I'll try not to write, okay? As you can see, for beryllium, magnesium, and calcium, the number of electrons in the outermost shell is 2. And that's what's common in all of the elements in any of the groups. Now, if you pay attention to the last group there, which is being written as group 8A here, you will see they have got just the same number of electrons in the outermost shell. Helium, that's 2. because that's a different kind of atom from neon and argon. But you can see for neon and for argon, the number of electrons is 8 each in the outermost shell. And that's what the answer for your question is. Let me go to your class. And this one. So what do the elements in each group have in common? In each group, all the elements must have the same number of electrons in the outermost shell. That's your answer. Some people call, like we also call, we have got a special name for the electrons which are present in the outermost shell. They are called valence electrons. So Majgan, if somebody asks you, what are valence electrons? You just answer by saying the valence electrons are nothing but they are the electrons sitting in the outermost orbit or outermost shell of that atom. Now, what are electron shells? What I'm talking about, you need to do style lessons first. If you need to know about what I'm saying or what is the meaning of shells, electric shells, energy shells, you need to do the style lessons first, okay? Now, next question. What do the elements in each period or row have in common? Now, let me pick the first row, not the first row, second row. By row, I mean the periods, okay? So this one is the second row or second period of the periodic table. It has got elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. It's missing few, but for our purposes, for our task, I have just confined our research to these elements only. It's not the complete periodic table in itself. It's missing too many elements. Now, what do they have in common? They all have the same number of electron shells, 2 in this case. So, if you observe carefully the periodic table, you will come to know if you are talking about a particular period, the number of that period is nothing but the number of electron shells involved. If you see first period there, this means the first row. It has got 1 shell. If you have a look at the elements in period number second, all the elements have got 2 shells. If you look at the elements sitting in period number 3, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon, they all have 3 electron shells. And that's the common thing that they're sharing if they belong to the same period. All right, guys? So before I finish the recording this important video, I need to tell you 2 important points. If you are talking about a group, whatever the group you're talking about, all the elements in that group will have just the same properties. By group, I mean the columns of the periodic table. There are 18 groups in the periodic table. All right? What do they have in common? What do the elements sitting in one group have in common? They all have the same number of electrons in the outermost energy shell. It can be 1, 2, 3, 4, 5, 6, 7, 8. Not more than that. But all the elements have the same number. In the same way, if somebody asks you, what is so special about the elements sitting in any one period? You just say to these, you just answer by saying, in any of the periods given there, all the elements in that particular period will have the same number of energy shells. It can be 2, 3, 4, 5, and so on. Hopefully this video makes sense. If not, please send me another email and I'll try to explain in some other way. Okay, see ya.